All right, let's go and review some things we talked about. Over the last several lessons, we've been working through an entire chapter on conic sections. And what are the 4 conic sections we've been working on, Jamie?
Circle, parabola, ellipse, hyperbola.
Good. In that order that we've taught them, the most basic of all the conics, of course, is the circle, which is really defined as the locus of points having a... This is something we memorized in geometry last year. Locus of points having a given distance as radius from a given point called the center, right? And from there, we moved on to the parabola, which is defined as the locus of points that are...
same distance from a line and point.
Equidistant from a point called the focus and a line called the directrix. Then we moved on to the ellipse, which is defined as the locus of points having a constant sum of distances from 2 fixed points called foci. And now we're to the hyperbola, which is defined as the locus of points having a constant difference of distances from 2 fixed points called the foci. As far as the conic form, remember we said everything falls into the basic form ax squared plus by squared plus cx plus dy plus e equals 0, since we're discounting the xy term. We said for a circle, what's always going to be true, Jamie?
There will be x squared and y squared.
True, but there's 2 other conics that will be true for.
One will be
for both
x squared and y squared.
The a and the b values, the coefficients of x squared and y squared will have to both be positive 1. What about for the parabola? What was kind of the unique thing? Quentin?
The a and b were different.
For the parabola? Jamie?
That was only 1 squared.
Right, either a or b had to be a 0. There was no x squared or no y squared present. Then for the ellipse, coming back to Quentin here, a and b both have to be positive, but different values, different numerically from each other. And then finally with the hyperbola, Jamie,
There has to be a difference.
so either a or b has to be negative. They could even be the same numeric value or absolute value, I suppose you could say, but the signs have to be different on the a and the b, and that's where we were with that. The ellipse and the hyperbola, similar in this respect, that in their elliptical and hyperbolic forms, both of the equations are set equal to 1. And so on page 251 from the homework, number 1a, as we were given a 9x squared minus 16y squared equals 144, we see that the a is a 9. We see the b is the negative 16. We notice there is not an x to the first or y to the first, so c and d are both 0, and the e or the constant's already been kicked out. Right? What this means, the fact that there isn't a cx or a dy term present, just means that the origin of the hyperbola class is going to be 0, 0. The presence of an x term and a y term and or a y term tells us it's translated. The origin is from its usual spot. But to get it equal to 1, what did we have to do first, Jamie?
We have to divide everything by the 144.
And when we do, what did we get?
X squared over 16 minus y squared over 9 equals 1.
There we go. And so now we were able to analyze several things about our conic. Of course, the center we already knew was going to be at 0, 0. But what about the, there were 2 axes that weren't actually part of the hyperbola, but actually in between the 2 branches of the hyperbola, remember? And those 2 axes are called the
Transverse axis and the
conjugate axis, the transverse axis and the conjugate axis. Remember, the transverse axis is what runs between the 2. Well, the vertices are the foci are on the extension of the transverse axis, but the transverse axis is what runs between the 2. I just said it by accident. Vertices. Remember, the vertex of a parabola would be where it changes direction. Same for the hyperbola. And running right between the vertices is the transverse axis. And that's the next thing that we'll always analyze, is which axis is the transverse axis and which one isn't it? How do we tell, Jamie?
And it's the x.
How do we know?
It's positive.
Not because it's bigger, but because it's positive. Now, we like it if it's bigger, but it doesn't matter that it's bigger. It matters that it's positive. The x-axis is the transverse axis, which means, obviously, the conjugate axis class will be the y-axis. Pretty straightforward there. For the length of the transverse axis, we said we're going to look at the number that is below the positive, and we're going to represent that number, class, as a squared. But the transverse axis, each side of it is only a. So therefore, each side of the transverse axis is 4 each. That means the whole length would be 8. By the way, this midpoint, remember, of the transverse axis is called the origin, and the conjugate axis will run between it. Now here, the conjugate axis is represented b on each side, but this is b squared, the one that's under the negative. Conjugate axis is how big, class? 3 each. And so a little bit shorter conjugate axis than transverse axis. Now, this line is really meaningless, but these two axes together give me a little box we call the
Yeah, it's a rectangle.
something rectangle, yeah. Fundamental rectangle of the hyperbola. And really, I only care about the corners. I mean, I could draw the whole box if I wanted, but I really only care about the corners because the corners give me the asymptotes. And again, this is the only conic that has the asymptotes, and you can tell this is very poorly drawn because I'm all over the place with these asymptotes, but it's just a rough sketch. Right? We should stay inside the asymptotes. The foci, remember, fall along the extension of the transverse axis, but the focal length is measured not from the vertices, class, but from the origin. In a parabola, you measure from the vertex into the focal length. In the hyperbola, you measure from the origin to the focal length. Same as with the ellipse, you go from the center to the foci. So how do I find focal length for a hyperbola, Quentin?
A squared, or the square root of a squared plus b.
Good. Like the ellipse, square root of a squared, b squared, but in the ellipse, you're subtracting the squares. In the hyperbola, you're adding. So we get the square root of
25.
Which is just. So from here we go outward 5. Again, we were already 4. 1 more puts us at a focal point, and 1 more puts us at the other focal point. Finally, to help define the shape, the asymptotes are helpful, but we also have the ends of the 2 focal chords.
Lateral rectum.
The lateral rectum. Of course, we'll just measure half lateral rectum using the formula.
B squared over 8.
Good. If you want the whole thing, 2b squared over 8. We always just do halves because I think it's easier. So b squared over 8. Again, your b squared here, your a is just 4, so the half lateral rectum?
2 1/4.
2 1/4, or 2 1/4, 2.25. So you go up and down a little bit, and you'd use those points to help to define your shape. And that's approximately what we should have done here. Again, it didn't look exactly like this, but there's the analysis. Let's take a look at the graph very quickly. And the unfortunate thing with the hyperbola is you pretty much need a new Cartesian plane for every graph that we do. Definitely a bummer. Let me zoom in just a little bit here. Jamie, I trust you found that zooming in helped as you were stuck watching the video yesterday. Glad to have you back. Quentin is glad to have you back. I think he still said you should watch out on pizza day, though. So. That red sauce, though. All right, so again, you'll start at the center. And I call it center. We don't call it the center. That's the ellipse, the origin of the hyperbola. Along the x-axis, you should have gone 4 in each direction, up and down 3. And that gave you corners like so. You took your straight edge, make your asymptotes, and then focal length, another 5th unit out in both directions, up and down 2 1/4, which is not much past the 2, a little bit past the 2. Oh, from the focus, not from the vertex. From the focus up 2 1/4, down 2 1/4, and then get the curve. Like so. We have something like that for 1A from the homework. Checking your work. Question, Quentin.
For my calculus right now, I have 1.3. I don't know how I got that.
Okay. You understand now?
Mm-hmm.
All right. Questions at all? Go ahead and clear your desk if you would, sir, except for a pencil. All right, let's take a look at translated origin now. And that's really the algebra behind it, is getting to that center point. Watching out for the negative, remember, is really the biggest key when working with the translated origin. Flipping the page, page 252, number 10, letter A. And this one, they already did most of the algebra for you, really. We have an x negative 3 squared minus y negative 2 squared all equal to 4. And Jamie, walk me through.
Divide everything by the 4. So that we get a 1 that side. And we have the origin, and the origin is going to be 3, 2. Figure out which was the transverse axis, and so when that's positive, so x. And it'll be 2 on each side. And for the CA, it'll also be 2 on each side.
Okay, so both transverse and conjugate axes the same length, which means your fundamental rectangle will be a square.
And the focal length is the square root of 8, or 2.8. And 1/2 of the last rectum is 2.
All right, so let's see what the graph should have looked like here. This will be, I think, the first time this year we've graphed one with a square rectangle at the middle. Don't need to make it super big. But I do need to do a lot for the shift, right? We're going to shift over to the first quadrant, over 3 and up 2. Did we start with our center, or our origin rather, here?
It was 3, 2.
You went 2, 3.
Yeah.
I can see it on your paper now, okay? So just be careful with reading the coordinates correctly. A new x prime axis. And along the x prime axis, we'll go 2 in each direction to the vertices. Up and down 2 to get the corners of the rectangle. Asymptotes through. Focal length 2.8, so almost out to a third in both directions. And then from there up and down 2. I think that's why it's important that I use a straight edge, because I feel like, yeah, my asymptote was really messed up there. And that's messing up my curve, so straight edge would really help. I'll grab that. How do we do? Other than the shift, Jamie, everything else good?
Yes.
And Quentin, good to go. All right, so no real algebra there on A. How about letter C? This one has got some algebra. So here we go. Quentin, it will fall to you to navigate the algebra on 10C. We had a 4x squared, negative y squared, negative 4x, positive 6y. They already ditched the 12 for you. Very similar to the ellipse as far as the algebra, but watch out for negatives twice. Go.
4x squared minus 4x leaves 1, and negative y squared plus 6y leaves 1 equals 12. Pull out the 4, so x squared minus x.
Ooh, that's another twist.
Plus 1/4. Then pull out your negative y squared minus 6y plus 9.
Good.
Adding a negative 1 and a 1.
Okay, you said negative 9 and positive 1.
Or yes, that's what I meant.
Okay, it sounded like you said negative 1 and positive 1. Like something's not right there. Right, so here this becomes a 1 that we add to the other side as well, and a negative 9, which we also put on the other side. So here, it's not super pretty, but it's also not the end of the world. 4 times the quantity.
X minus 1 half squared.
And then minus,
Y minus 3 squared.
all equal to
4.
4. So to set it equal to 1, our final form is
X minus 1/2 squared over 1 minus y minus 3 squared over 4 over 7.
And there we go. Now, Jamie, you weren't here yesterday. From the video lesson that you ended up having to watch, were you able to pick up on the process?
Yes.
Watching out for the negative. Now, the trick here is half is a half, squared is a fourth, and so therefore a 1 is what gets copied over. So it's a little obnoxious, but I mean, a half 3 isn't a bad shift for our origin. Let's take a look at that graph now and see what that'll look like. Finished? Want to bring it up? Feel like you got it this time? Alright, so again, not much of a shift, though we do have an upward shift to brace ourselves for. So if anything, I might set the axis a little bit lower than usual. Alright, so origin should be where, Jamie?
The origin is 1/2 3.
1/2 3. So here's half 3, and my my major, or not my major axis, my transverse axis is going to be along the X again. They keep doing that, but I'm really thankful this time because I didn't want to have to draw an axis down the half. To be honest with you, it's a little easier to keep track right here on the 3 line. So I'm thankful for that. Then the length of the transverse axis, Quentin, only 1 each. So we're going to go to right here to a vertex and here to a vertex, while the conjugate axis is 2 each. So we're going to go up to 2 and down to 2. So we're going to have to set our corners here and here, here and here. And definitely glad I have straight edge now. Get our asymptotes. Now obviously we see that this time the transverse axis is shorter than the conjugate axis, which means we're going to get a flatter hyperbola. All right, focal length, Jamie.
The focal length is 2/5.
Which is
2.2.
about 2.2. Now remember, not 2.2 from the vertices. 2.2 from the origin. 1, 2.2, and then 1, 2.2 puts us right about here. And then the half lateral recta, a little bit longer this time, Quentin. 4 in each direction, right? So up 4 almost gets us to the asymptotes in both cases. We're not real far off of the asymptotes. In fact, here I'm touching them, so again, maybe a little bit of an issue with my sketch, but yeah, really hard to avoid touching when the asymptote's a little out of place. Here I was able to do it, and then stop just short of that one. So again, if this is graded, tweak that asymptote line just a little bit there. But should have had something like that. How did we do on letter C, 10C? All right, last one from the homework then was 10E. 10E. And Jamie's turn with the algebra. We have a negative 3x squared, positive 9y squared, positive 12x equals 48. Jamie, go.
Thatcher, we'll go ahead and group the negative 3x squared plus 12x. Then just have a 9y squared factorial. Thatcher have the negative 3. And we'll look at x squared, negative 4x. And then we'll complete the square with a positive 4. And that'll become a negative 12 on the other side.
Good, because it really is a negative 12 right here. It just looks like a 4.
Then it'll be negative 3x minus 2 squared plus the 9y squared equals 36. then divide everything by 36. And it'll be a negative x minus 2 squared over 12 plus y squared over 4 equals 1.
All right. Well, let's go ahead and get ready to analyze and graph this one. For sake of time, I won't write the analysis like we did on the last one. We'll talk through it. Hopefully you did have the analysis. All right, Jamie, the origin of the hyperbola.
2, 0.
So I'm going to shift it forward just a little. We'll set the y-axis back just a little bit, not a lot. Let's give me a little extra room here. All right, so 2, 0. All right. The transverse axis.
Is y.
Along the y, so we'll have to draw a new y prime axis.
Then it'll be 2 each on the transverse axis.
2 each on the transverse. And on the conjugate,
3.5.
yeah, square root of 12 each, which is about 3.5. So you're right about here, right about here. So our fundamental rectangle is going to have those halves in it. And we'll use that rectangle to get the asymptotes. There it is. All right. Focal length.
4.
Exactly 4 this time. So that makes it easy. Again, not 4 from the vertices, but 4 from the origin. So you're only 2 away from the vertices. And then the half lateral recta.
I have 6.
Exactly 6. So puts us close to the asymptotes, though not right at them, which is helpful. And then over 6, over 6. And something like that is what we should have had. And how we do on 10E, the last homework problem?
And me drawing the thing wasn't too good, but besides that.
Okay, all right. All the analysis was correct, and we just got to work on smoothing it up over the next couple of lessons. All right, let's go and tackle number 10D. Number 10D at your seats. There's a couple more of these, and then we'll change gears a little bit, which I think will be a bit of a welcome relief. I'll make sure we have mastery of the basics first, though.
Which one is it?
10D on page 252. Number 10, letter D. true negative v and not a u. Hyperbola here, that's a beautiful v, that's good. But, you get post generous. Always close to parentheses. Right here, we got the 4. You see there's also x's and y's. Be greedy, make like the government here, if you can. So the way to save it would be even from here. I can pull the x's and y's out, tack it on to the 4. Now I'm left with this 2 and 5 and 4. Start with a 4x, so I can get the same answer. And then here, the only problem is right here, you take radical 4 to get 1. You just get the radical 4. So just be careful with that, but otherwise a lot better. Again, you'll take that test tomorrow. Probably during the class time, since you have the ability to go back and rewatch. I'll probably make up the English during study hall. But, check your algebra. We're good to go on the form, getting it into the elliptical form.
I have positive 1 with the y for some reason.
Alright, do we see here when we take the negative out, changes to a negative, hence the negative there. All right, questions on 10D.
So for the origin, the y is the 1.
Right, negative 1, 1. So back 1, up 1.
Okay.
We're going to use the x-axis because it's out the positive. Then 1 each, so a fundamental square as a rectangle. Focal length 1.4, half lateral rectum 1.
Negative 1, negative 1?
Yeah, that's fine. I'm going to.
Because it was plus 2y.
Okay, so I pointed this out a moment ago. Let me point it out one more time. So in the form, right, we start here. We got to group the x's, which are both positive, and the y's where the y squared is negative and the 2y is positive. You have to factor out that negative though. So it changes it to a negative 2y, so therefore when you complete the square with the 1, for one thing, it's a negative 1 as it comes over here, but also you get a y minus 1 in the parentheses. Right, like if I had a negative 3y squared positive 27y, when you pulled out the negative 3, you'd say y squared minus 9y, right? But it wasn't a 3, it was just a 1. It was just the negative itself, but it still changes the sign even if the number's a 1. Make sense? All right? And that totally didn't show up on the camera, but that's okay. That's what I was talking about a second ago. Good. Any other questions on this one? So a little bit tricky. Watch out for things like that. Let's do one more of these, and then we'll transition. Letter F. Letter F. And this should give you good practice with the whole process and not as tricky, I don't think. All right, check your algebra. All right, how do we do on 10D? 10D. Any questions on graphing the hyperbola? All right, so we should be ready for a quiz over this in our next lesson. We'll do a little bit of review in our next lesson before the quiz, but as we have done with the other conics, I want to go about finding equations from some given information. So you're there on page 252. Look at number 11 and read number 11 through part A for me, if you would. Jamie?
Find the equation of the hyperbolas given the following. A, origin at 1, 3, transverse axis equal to 4, parallel to x-axis, conjugate axis 6.
All right, so in the equation form, what do I need to know about my hyperbola to get the equation?
Your origin.
I need the origin.
Your focal length.
I don't need the focal length for the equation.
Oh, for the equation, okay.
What the transverse axis?
Which one's transverse? And of course, that's kind of, your positive, negative.
For the, how much?
So the,
Conjugate axis and the transverse axis.
right, the a squared and the b squared, right? I need to know those values. So if I know these things, I've got what I need. Well, on letter A, they tell me the origin, so that's already a go, right? It's translated to 1, 3. It tells me the transverse axis is 4. Well, if it's 4, that's 2 each side, correct? So that tells me a squared is 4. Tells me the conjugate axis is 6. So b squared must be
36. Well,
6.
9.
3 on each side, so 9 is going to be the b squared value. But then it tells me one more important thing. It says that the transverse axis is parallel to the x-axis. In other words, an x prime axis. So we've got the origin. We know transverse axis is going to be along the x, parallel to the x. We know the a to b. What's the equation going to look like, Jamie?
X minus y squared over 4 plus or minus y minus 3 squared all over 9 equals 4.
And for our sake, we're not going to convert it into the conic form, but we could, right? Multiply everything by 36, square the binomials, get it in the conic form. We could do that for sake of time. We won't. There we go. Good. The origin's 1, 3, so we know we got that. We're going to put the positive with the x, the negative with the y. The 4 goes under the x, the 9 goes under the y, equal to 1. Seem pretty straightforward? Look at letter C. Quentin, what are we told in letter C?
vertices 0, 4 plus minus 2, conjugate axis equals 6.
Well, they told me the conjugate axis was 6. That's kind of similar to the last problem. So the conjugate axis is 6, class.
So 9 is your b squared.
9 is the b squared. Okay, so I've got one of these things. That's it. The other information doesn't directly tie in here, but we can make it tie in. It says the vertices are at 0, 4 plus or minus 2. Thoughts?
Vertices are at 0, 6, and 0, 2.
Okay, so picturing this here, 0, 6, 0, 2, these are the vertices. So what does that tell us?
That your transverse axis is the y.
Okay.
The origin is 0, 4.
Ah, right here in the middle, the origin is 0, 4.
And then your a squared is 4.
Good. There's 2 on each side, so 2 is the a squared is 4. So, Quentin, what's the equation? Oh, I just realized my camera might have cut some of the last one. I'm sorry if that's the case.
Negative x squared over 4, or over 9, actually, plus y squared over 4. Y minus 4.
There we go. Y minus 4 squared. That gets the translated origin. Fine to say x squared. We don't have to say x minus 0 squared. But the x squared over the 9, the y minus 4 squared over the 4, of course, negative on the x, positive on the y. And there we go. Questions on that one. Let's take a look at letter B. And that'll kind of wrap up our hour here. Letter B, Jamie, what are we told?
Foci, 1 plus or minus 3, 2, conjugate axis equals to 4.
Okay. So we need the a squared, we need the b squared. Well, they told us at least something really, really straightforward.
Conjugate axis.
So therefore,
B squared is 4.
all right, so we got that out of the way. Foci. So f and f prime are 1 plus or minus 3, 2. Thoughts?
4, 2, and negative 2, 2.
Okay, so again, kind of a quick sketch here. 4, 2, negative 2, 2. These are the foci. So that means somewhere along here are vertices. Somewhere along here is an origin, right? So the curves are going to do something like that.
Transverse axis is the x-axis.
Okay, so the x-axis is transverse.
A squared is 9.
Careful.
The origin is 1, 2.
The origin is 1, 2, right? Right here between the foci. But this, from focus to focus, is 6, not vertex to vertex 6. Do you see it? Oh. So therefore, we would say from O to F is 3. But what do we call O to F? Focal length. The focal length, that's a horrible L. The focal length is 3. We know that B squared is 4. We would normally represent the focal length with the letter C, remember.
So square the 3, and then subtract the b squared. So a squared is 5.
A squared is 5. There we go. Follow? So, what's the equation of this particular hyperbola? Either of you?
X minus 1 squared over 5 minus y minus 2 squared over 4 equals 1.
Perfect. And there we go. Question on that? We see how to think through. It's really the same key to thinking through everything. With the circle, it was, okay, all I really care about is center and radius. With the, for the equation's sake. For the parabola, all I cared about was the vertex and the focal length. For the ellipse, it was the center, major axis, and then the lengths of the sides of a squared and b squared. Here it's origin, transverse axis, a squared and b squared. And you figure it out, put it together, sketches help. Questions at all on this? All right, no homework this evening. Next lesson, we'll do a quick review over hyperbolas. We'll take a quiz. We do have a test coming up in lesson 153. So tomorrow, in our lesson, we're going to wrap up the hyperbolas. The following lesson will be lesson 152. We'll be reviewing for the test. And then lesson 153 will be test 10 over all things conic sections. Test over chapter 12, coming up in lesson 153. Have a wonderful rest of your day. And when the bell rings, you are dismissed.